Remember when we started this section and I was talking to you about applications of why do we even bother doing composite functions? And we looked at the Exxon Valdez as an example of when the oil spill and the radius was changing. And then that meant that the area of the oil spill was also changing. So this is something similar. I'm not quite sure what the backstory is, but we essentially have an object that has a surface area to it, and your radius is changing. So this is the equation with respect to time, and of course your t is going to be greater than or equal to 0. We do not time travel in here. So with r of t equals to 5 over 7 t cubed, that means this is my rate of change of my radius. This here is my surface area. So my surface area changes as my radius changes because my radius is a component of that. So do you see where I have an r in here? That's the variable that changes. So that's my input. That's my dependent variable, right? Or independent variable. And then here I'm doing r with respect to t, and that's rt. So, well, r goes into here. So r is actually going to be the inside guts. So let's go ahead and rearrange this and call it S of r of t. Do you see how we just kind of pack that out? So we're going to do a composite functions to see how the surface area changes based on time, because time is going to affect your radius and your radius will affect your surface area. So let's go ahead and look at this. I don't have any substitutions, so I'm going to go from the outside in. So let's go ahead and write that outside function. So that's going to be 4 pi and then r squared. So that's my outside function. Then what I'm going to do is take the inside guts and get them in to substitute in for that. So I have change color here, 5/7 t cubed. All right, so that whole inside has to be squared. And I don't know if you guys remember from Algebra 2, but when you have something to a power and then you square it, you're going to actually multiply them. If it was just t to the third times t squared, you would just add them. So here we're going to go ahead and multiply those. So we have 4 pi times, let's square my 5, so that's 25, over square my 7, that's 49, and then that t gets multiplied by this 2, so that's t to the 6. Well, then I can take that 4 and multiply it by 25. So when I do that, I end up with 100, and let's keep my denominator here, so I have 49. And then the whole thing is times pi, and then t to the 6th. So that would be how your surface area changes with respect to your radius given a change in time. So this is going to be your composite. You will have different examples than this, but the idea is to look to see what's in common between both of your functions, and one will sit inside the other, and that tells you the order that you want to have your composite function.